Hi students, this chapter we will be looking at acid and bases. So what is an acid? Acid by definition is a substance that dissolves or dissociate, or some schools use the word ionize, in water to produce hydrogen ions, your H plus ions. Okay, so acids, if you look at it, these are all chemicals that you are constantly using in your school lab, and they are all what we call colorless solution. So common examples of acid, we have the hydrochloric acid, nitric acid, sulfuric acid. Okay, so your hydrochloric acid, nitric acid, and sulfuric acid, this comes from your polyatomic ions. Remember, nitric acid comes from nitrate. Okay, nitrate, the formula is NO3 minus. So for it to be an acid, the formula for acid is H plus. That's why when you balance out the charge, or when you do the cross multiplication method, your formula will be HNO3. Okay, the next common acid we have is your sulfuric acid, which came from sulfate. So sulfate is your SO4 2 minus, and that's why your sulfuric acid is H plus, and SO4 2 minus, you will get H2SO4 when you do the cross multiply, or when you're trying to balance out the charge. Okay. For those who are doing pure science, we also have what we call the sulfurous acid, carbonic acid, and phosphoric acid. Okay. We also have other kinds of acid from organic acids. So these acids come from plants and animals. A very common organic acid that we have to know is over here. This is your ethanoic acid, which is found in vinegar. So ethanoic acid, the formula is CH3COOH. Okay, the compound looks like this. Since they are all non-metal binding to non-metal, it is covalent, so they share the electrons. So you have carbon, which can form 4 bonds because it has 4 outer electrons. This carbon is bonded to another carbon, and then each carbon is actually bonded to a hydrogen atom. So 4 lines coming out, and then this second carbon, you have 4 lines coming out as well. Your oxygen can form 2 bonds. So 2 lines from your oxygen. Okay, so this is what the compound looks like, your ethanoic acid. So acid by definition, it dissociates to give your hydrogen ions. So over here, which H will be dissociated or ionized in water. So it's really this H, okay, that's connected to the oxygen. This one will ionize to give me CH3COO minus plus H plus. This H, the last H over here, gives it the acidic property. Okay, so generally speaking, we have the properties of the acid. Acids have a sour taste and they are corrosive. So sour taste is very common examples of acids in your daily life. You have the vinegar, lemon, orange, your citrus fruits, and then Coke. Why is it corrosive? Generally for Coke, for example, if you drink Coke and then you don't brush your teeth, overnight, if you rub your tongue through it, you will feel that there's a layer. So this layer is really the acid from Coke corroding the calcium compounds in your teeth. Okay, the next property is good conductors of electricity in water. So why are they good conductors of electricity? Upon dissociation, or upon if you're trying to dissolve it in water, okay, it will dissociate to form your hydrogen ions, and then these ions, for example your HCl, which is gas, I will put it inside water. Okay, and then this HCl gas, when I bubble it into water, it will break out into H plus and Cl minus. And then these ions, they act as what we call charge carriers to conduct electricity. Okay, and then acids are also poor conductors in organic solvent. Being covalent, they cannot dissolve in organic solvent. Organic solvents are any name that you haven't seen before. For example, methyl benzene. Okay, that's going to be an organic solvent. Why is it a poor conductor in the organic solvent. This is because being a covalent compound, they cannot dissolve in the organic solvent. So there is no dissociation, and then there is no charged particles to conduct electricity. So picture to illustrate the first one, you can see your individual ions are dissociated, your H plus and your Cl minus. So these ions will be free to move in water, and then they can conduct electricity, your bulb will light up. But if you have HCl gas, you dissolve it inside methyl benzene over here. Never see before the name is an organic solvent. So when it dissolves, it actually cannot dissolve inside the organic solvent. They remain as molecules. Each one of them is still a HCl molecule. So there is no charged particles. They cannot conduct electricity. Your bulb doesn't light up. Okay? And then the last physical property that we have is acid have a pH of less than 7. And then it will turn blue litmus paper red. Okay, this blue litmus paper, please remember to write the word moist over here. Why moist? Because if it's not moist, how does it dissociate? By definition, it dissociates in water. So you need the moisture to release the H+, which gives the acidic properties. Okay, so it turns your blue litmus paper red, and then the universal indicator, it turns orange or red. Okay, acids, please remember this, acids will only show acidic properties when dissolved in water, meaning to say when they dissolve in water, you can get the H+, and the H+ will give all these physical properties that we just talked about. If it's dry and it doesn't dissolve, then there is no H+, it will not show signs of acidity, it will not be sour, it will not be corrosive, it cannot conduct electricity. Okay, so if we look at this checkpoint over here, a very common example that they will ask you. So effervescence tablets come in solid form. So solid form, you should know this is dry. Okay, effervescence means bubbling. Okay, so when it is dry, there is obviously no bubbles because these are just tablets, not tables. Okay, but when dropped inside a glass of water, it quickly fizzles. Fizzles means bubbles, right? And then it dissolves. So inside these effervescence tablets, what are they? They have solid citric acid and a carbonate compound. Okay, carbonate, remember, is CO3, 2 minus, and this one will usually give me CO2. Okay, in solid form, there is no water. The tablet does not dissolve, okay? When exposed to water, the solid citric acid dissolves, and then it dissociates or it ionizes to release your H+. So the H+ in your citric acid dissociates. So the H+, they are free to move, and then these H+ ions, the hydrogen ions, give it the acidic properties. So these acidic properties means that this citric acid now can actually convert your CO3 to CO2, and that's why you see fizzling or effervescence. Okay, the next thing that we are going to look at is what we call basicity. So basicity means how many hydrogen ions can one molecule of acid produce. Okay, common monobasic acid is your HCl. Okay, HCl, which is gas, if you put it inside water, it will dissociate to give me H+ plus Cl minus. Okay, and then dissolving, we talk a little bit about the state symbols. This one is aqueous. Dissolving in water, the state is always aqueous. Okay, so if you have one HCl, it gives me one H+ and one Cl minus. One H+ meaning to say this is a monobasic acid. Okay, next common example, we have what we call the dibasic. So dibasic, di means 2. So if now you have one H2SO4, this one will dissociate to give me 2 H+. Okay, plus SO4, 2 minus. So 2H+ is a dibasic acid. Okay, this basicity will be true for alkalis. Later we will see what is the alkalis. So under our learning syllabus, we also need to know the uses of your sulfuric acid. So memory work over here, car batteries used to manufacture soap and detergents, and then used in fertilizers and explosives. Okay, next one we have controlling soil acidity, or generally pollution, in the environment. Okay, most of the time this pollution is caused by, or rather the acidic condition of our environment is caused by pollution. Okay, to control acidic environment or pollution in the environment, we have to use what we call the calcium compounds. Okay, it must be calcium compounds, and then these calcium compounds, there's a general name, we call them lime. Okay, so your lime water or the slaked lime is your calcium hydroxide, limestone is calcium carbonate, and then lime is calcium oxide. Okay, repeat, we can only use calcium compounds to control environment acidity. Okay, this part over here will be good for the O levels, pure science, and then the IT level. Okay, so strong acid, by definition, it dissociates completely in water to produce high concentration of hydrogen ions. Okay, the two acids or the three acids, HCl, H2SO4, and then your HNO3. Okay, your hydrochloric acid, sulfuric acid, and then your nitric acid. These are all strong acid. So definition, they dissociate completely. Okay, so if I have, for example, if I have 10 HCl molecules, it will dissociate to give me 10 H plus 10 Cl minus, all the 10 separate. Okay, for it to be a weak acid, we dissociate partially. So dissociate partially, it produces low concentration of H plus ions, hydrogen ions. Okay, so now if you have 10 CH3 COOH, at any point of time, maybe you will only have 5 H plus and then 5 CH3 COO minus. And then you will also have 5 CH3 COOH that remains as molecule. They don't dissociate, that's why you have low H plus. And then this is your weak acid. Okay, picture wise, your strong acid, all the molecules dissociate, but your weak acid, this one haven't dissociate. Okay, this one separate, these two already separate out, these two dissociate. Okay, next one we have what we call the concentration of the acid. Concentration of acid refers to the amount of acid per unit volume. Okay, and then this has the units of either gram per dm cube or mole per dm cube. Regarding mole, you will learn it next time in term 3, most of us, so don't worry too much about it first. Okay, let's look at this gram per dm cube. Gram just means mass, right? And then dm cube really just means 1000 cm cube, means 10 cm by 10 cm by 10 cm. So this gram per dm cube means how much or how heavy or what's the mass of my HCl. I put the mass of HCl in a 10 by 10 by 10 cm cube container, and that's your concentration. Okay, please don't confuse this. The strength of an acid is not the same as the concentration. Okay, you can have dilute strong acid. We can also have dilute weak acid. So an example of this dilute strong acid will be 0.01 grams per dm cube for the metal, and then a dilute weak acid. Okay, a dilute weak acid will be still 0.01 gram per dm cube. In this case, you have your CH3COOH. Okay, and then you also can have what we call a concentrated strong acid. Your concentrated strong acid, maybe you have 10 grams per dm cube of HCl. Okay, this idea of your dilute and concentration, we will look at it more in detail when we do mole concept, mole calculation.